All right, so here's the CNC machine modeled up. The spindle is conspicuously absent. This little thing down here is my model for the spoil board leveling bit. And so basically sort of a little intro to tramming. I assume everyone here watching this knows what tramming is. But just in case. So your gantry, as it moves in both the X and Y direction, essentially create an imaginary plane here. And that plane, the whole goal of this is to get this spoil board to be completely parallel to this plane. And so in order to do that, we have to tram the spindle, which means rotate it in both this dimension and this dimension so that this bit is perfectly parallel to that imaginary plane, and then we go and surface the spoil board. And so a really common way to do that is to use one of these, which is a spindle tramming square. And so they're not that expensive. It's probably, it's $100. I don't know. I've never used this particular one, but it might it might be a good investment if this is something you're doing on a regular basis. Obviously, these for machinists use it in many different scenarios. So anyway, this may be where I end up, but since I'm a build it rather than buy it kind of guy, I'm at least going to try to tram it first without it, and then see how we do. So let's get started. So right now I know that the spoil board is not parallel to the gantry. It's probably maybe a 3/1000ths difference between the left side, and then front back is probably about the same. So anyway, the plan here is I've got this it's just a piece of tempered glass. It's a shelf. And So the goal here is to level this piece of glass to become parallel to the motion of the gantry in both the X and the Y axis, and then use that as the reference plane to tram the spindle. So once we know that the head of the bit is parallel to that imaginary plane, then we can level the spoil board and make the spoil board parallel to that plane. So initially I was trying to level this piece of tempered glass using sheets of paper and these razor blades, which are a pretty consistent thickness, but I was having trouble. No matter what I did, it seemed like I was getting little valleys, and the glass itself was teetering rather than laying flat. So I wanted to switch to this, so I basically I had some coupling nuts, and bought these are M8s 1.25. I think a little finer thread pitch would have been nice, but I couldn't find a coupling nut that was for that pitch. So hopefully these will do. Anyway, I put them together, and they're just little poor man's machinist jacks. And so hopefully it'll allow me to level this thing a little better. So one of the weird things I'm having to do here is put some thread dope on these threads, because there's not enough friction, and I'm finding it difficult to finely tune the height, so this should just make it a little bit sticky. And allow my rotations to be very purposeful rather than random. The glass actually has a slight bow down. Either I need more jacks or I need to reduce the area by moving these jacks to the center. I don't really need all of this space. I just need a small area here to rotate. So this is the problem I'm having. My piece of tempered glass is actually teetering. It's quite a bit. It's like whatever, seven thou. And possibilities are that the plate of glass itself isn't very flat. But I think more likely is what it's caused by is that these feet are actually too wide. And so I'm going to try to make a pin to reduce the surface area so that those can, basically the pane of glass can level itself more completely. All right, so here's the solution. Took these little bolts, rounded over some ends, and I'm going to put them in these poor man's machinist jacks to reduce the surface area that the top makes contact with. Hopefully that'll stop the teetering. So yeah, that was kind of interesting. Basically creating those little round feet didn't help that much as far as the teetering was concerned. It just seemed to be a balance issue. I would get, I would set this to 0, say this corner, and then it would teeter, and then I would have to adjust this over here to get it to go flat. And so it was just a long amount of fussing, essentially, to get it both flat and non-teetering. So there you have that. All right, so here's the piece of glass leveled as best I can get it. So here I've gotten the glass plate as level as I can, and I put this piece of paper down, and these nuts are just weighing the paper down so the paper doesn't move as much. And then we're just trying to visually verify that the gap between the paper and the card by bit here is the same on this side as it is when we rotate over here. And then we need to do the same in the other dimension, which is front to back. So basically back there is that gap the same as up here in the front, and as you might be able to tell, it tightens up in the front. So that's indicating to me that the shim that I have in between here needs to be a little bit thicker. And I think that's basically the crux of the problem with this adjustment mechanism, is that when I'm tramming in this dimension, I literally have to undo the screws and then manually manipulate all this weight and try to adjust, very fine distances. And then the other dimension is just as bad, if not worse, because you take everything apart, then you make the shim thicker or thinner, and then put it back together, and then try to get one dimension and the other. And so ideally you would like, I could envision, there'd be 2 adjustment screws that had a very fine pitch that you could just dynamically do this, and then lock everything down. So that would be my desired solution, but that's not where we are. So there's the battle. Yeah, so I'm trying to I'm trying to sneak up on this thing. So that's a 0.01 inch down. And now these are minus, they're basically 1 thou down. Each one of those noises is 1/1000th of the z-axis down. Yeah, if I had to guess, if I had to say, I'd say this is getting, it's a little wider than it is over there. Really got to be careful about the paper moving, but anyway, one more thou. At some point, the paper will make contact. It'll make contact with the paper somewhere in its arc. I still have a feeling that right around here is the low spot. Yeah, so you can definitely see we're making contact here first. That it is. Yeah. It's really not bad. You know, it's like I'm not sure I can improve upon that. Well, we've gone 10 thou down so far, and we're just now making contact. I don't know, man. I'm with the crudeness of my ability to adjust that. I'm gonna have to call that good, man. Let's go one more thou and see if we hit. Yeah. I don't know. I think I'm going to call that. I think this spindle is trammed. Certainly within the best of my ability with these techniques. So I guess that's it for this tramming video. I think I'm going to postpone critiquing this process until I see how well this thing levels the spoil board and how smooth the spoil board is afterwards. But that's, I guess, for another video. Thanks for watching.